Welcome to the project demonstration of radiator based power generation and utilizing that power to the inverter. So here we have mounted the Peltier plate, the thermoelectric plates under this radiator. So with heatsink, and the heatsink will, in real time, this heatsink will act as a cooling plate, and this radiator will heat up due to the vehicle engine rotation. So due to the heating to this radiator, so this will provide the heat to the Peltier plate, which we mount in between these two aluminum plates and a radiator. So when the one side of this Peltier plate is heat up, then other side will use it to cool down the other side. Then automatically, due to the thermal effect inside the Peltier plate, there we place the PN junction diodes inside that, so which is size of 40 mm by 40 mm. Based on the heating and cooling effect, so it will provide the energy, that is the electrical energy. So that will be given to the charging battery through the charging circuit. So here we are using this charging circuit. So we can charge a battery. This battery ratings are 12 volt 1 amp. So this battery pack consists of 3 4 volt 1 amp batteries are in series. So we will get 12 volt 1 amp. So to charge a battery, we are providing two sources. One is our Peltier plate based on the heating, and also if there is no like energy generation from the Peltier plate, then we can charge this battery by using the transformer by providing the 230 volts input to this. So let us show you the example with transformer. When we switch on this, then the transformer will step down the 230 volts AC to 12 volts AC, and this regulated power supply board will convert that AC to DC, because we are using a DC battery. So then through this circuit we are going to charge this battery. When it is fully charged, automatically these diodes will stop the current flow from the battery to the transformer in order to protect the charging circuit and the transformer. So if you want to charge a battery with the help of our Peltier plates, so we need to connect this here. So P or T and B to the B over here. So once the battery is fully charged, so it will take 10 hours to be fully charged with the help of a transformer. Or if you want to charge a battery from the Peltier plate, as of now we are using the less size Peltier plate as it's available in the market, that much size only 40 mm by 40 mm. So we will get maximum of 1 to 1.5 volts based on the heating and cooling effect. So that voltage is given to the battery. So the DC power supply is given as input to this inverter circuit. So this inverter circuit consists of two main parts. One is pulse generation and there is a step up. So here using this one is the inductor L, and this small one is the capacitor C. So there is a LC oscillator which will provide us the 50 Hz oscillations, and that was given as input to this MOSFETs. So this MOSFETs will convert the 12 volts 1 amp DC to 12 volt 1 amp AC. So this step up transformer will step up the 12 volts 1 amp AC to 230 volts 1 amp AC. So that is the input to our AC load directly. So charging from the Peltier plates, transformer to the charging circuit to the battery, and here to DC to AC converter. So just we can utilize that. So we need to make the battery fully charged. So you should keep this for 10 hours. So let us see the demonstration for the heating concepts. Multimeter. Now let us see, you can see on the multimeter. So parallelly the temperature increases, parallelly the voltage will be increases. So both are proportional, right? Okay, in real time actually this is going to be act as a cooling plate, and this will act as a heater one. So as you know that this will be getting heat up while the vehicle is running, right?